Welcome to Algebra 1 with Miss Andrea. Today we're getting into lesson 5.10. That's 5.10, not 5.1. And what we're going to be learning is just one more way to solve quadratic equations. So this is in the book. It's listed, it's module 5, but the modules, the unit numbers, the names of it kind of got out of order. And so it's listed as unit 3, even though it's module 5. And the main thing to know is that it's solving quadratic equations. And this is page 10 of the online book. So module 5, page 10, that's why we call it lesson 5.10. And so let's get to it. We have an equation here, and if I asked you to solve this, your first thing would be to look at it to see if there's any common factors that you can take out of it, see if there's a way to factor it. So just looking at this, there's no common factors between all three terms, so I can't do GCF. There's no remember, we had something called difference of squares, but that only had two terms. It was a binomial, not a trinomial. So this is a trinomial, can't do that one. Then we had factoring trinomials with A being 1 or A not being 1. This case, A is 1, so maybe it could be that. Well, in that case, what I had to have was I needed to have something that multiplied to be 1, but added to be 4. So multiplied to be 1, but added to be 4. And so the only thing that multiplies to be 1 is 1 times 1. And we can't add those to be 4. So that's not going to work. So it looks like factoring just isn't going to work in this case. So we would be stuck doing the quadratic equation. Well, completing the square is a way to force factoring. If you prefer to factor over the quadratic equation, it's a way to force factoring when you have a prime equation, quadratic equation. So a polynomial that's prime or unable to be factored, we can force it to be factored. We can make that square peg fit into the round hole. So this is called completing the square. And the first thing that you want to do is you're going to take this last term and move it from the left over to the right. So I'm going to rewrite this. X squared plus 4x, and I'm going to leave a blank there, equals, if I move it from the left to the right, it's changing sides. And if it changes sides, it's going to change signs. So on the left, it's a positive 1. On the right, it needs to be a negative 1. Okay, so now the next step is we're going to take a look at this middle term right here, and it's going to help us determine what to plug in here. So I'm going to take 4 and I'm going to divide it by 2, and that gives me 2. And then the next step is to square it, and that's going to give me 4. Now, these two numbers are going to be important to us. Okay. We're going to take the answer that we just got, 4, and add it to both sides. Now, it's important that you add it to both sides because we have to keep our equation balanced. Remember, if you had something like x plus 2 equals 5, if I added 1 to just one side, would that change my value of x? Well, yeah, in this case, x would be 3, but in this case, x would be 2. But what if I added 1 to both sides? So x plus 2 equals 5, I added 1 to both sides. Did that change my equation? No, or not my equation. Does that change my answer? No, x is still 3 in both of those examples. So if you're going to add something, you have to add it to both sides. So x squared plus 4x plus 4 equals negative 1 plus 4. That's where I got the adding the 4 from. Okay. Now we will be able to factor this side right here. Now, if you remember, we had when when we found the difference of squares before, you had something like x squared minus 9, right, equals 0. And we would factor this out to be x plus 3 and x minus 3. So you had two factors, each with two terms separated by different signs. One's a plus sign and one's a negative sign. But what would it take to get to x plus 3 times x plus 3, or x plus 3 squared? What would it take to get to that? It certainly isn't going to be this up here, right? Not that. So let's see if we've got a cheat sheet for us. Here we have x squared plus 2nx plus n squared equals x plus n times x plus n. Now, real quick, x plus n is the same thing as x plus n squared, right? So this equation here is simply telling us that in order to get to what's over here, what you have to do is you're going to have a squared term at the beginning and a squared term at the end. And then whatever the root of that squared term is right here, times 2 is what's in the middle. Now, keep in mind, this is with a leading coefficient of 1. A leading coefficient of 1 is what should help us, trigger us to know we can do completing the square here. And so we've got x plus n squared. So this would be if we had this x plus 3 squared. So what would the expanded polynomial be for x plus 3 squared? Well, we know it's going to start with x squared according to this, right? And then we know it's going to end right here with, well, 3 squared. What's 3 squared? It's 9. But we need to figure out what's going to go right here in the middle. Okay, what's going to go in the middle? Well, it says 2 times n. And in this case, what is n? N is what's in the factored version right here. So 2 times 3. So we're going to have 6x. So this is equal. This is the bottom here is the expanded form of the polynomial. And this right here, the x plus 3 squared, is the factored form of the polynomial. So we need to keep this in mind when we're moving over to what we're doing over here. Let's go ahead and erase this so we have more room. Also, I want to say that this formula works also if there's a minus here. You need to do x minus n times x minus n. Okay, so, and that follows our same rules as before. When we looked at this second sign, tells us whether or not we have, if it's a plus sign like it is, it tells us whether or not we're going to have the same sign in both factors. And this first sign tells us whether or not what that sign will be in those factors. So you can do this same process with a minus here as the first sign instead of plus, and that's just going to change the sign that's in your factored form. All right, so let's get to it. So we have a factor here, and we're going to have x here, and then this number is going to be what goes right here, because that's the square root of what is what we added. And then it's a positive number because we have a plus here, so we're going to put a plus there, equals 3. X plus 2 equals 3, x plus 2 squared, excuse me. And now we need to undo the square root. Undo the square by doing the square root, excuse me. So we've got x plus 2 equals plus or minus square root of 3. That's prime. I can't reduce that anymore. It's just an irrational number. It's going to be there. So I've got x equals -2 plus square root of 3, and x equals -2 minus square root of 3. And those are going to be my exact answers. If you'd like to find your approximate answers, you can plug them into your calculator and figure those out round to the nearest 10th. So I've got written out for us the steps here. Step 1, the first thing we did is we moved this constant, or the c term, from the left to the right. So we're going to move c from the left to the right. So move c to the right side. And then step 2, we squared half of b. So we divided it in half and then squared it. So we divided it in half and then we squared it. Okay, then we add this number to both sides of the equation. That number that we got, we added to both sides of the equation, right? And then step 4, we factored it into this form, x plus n squared, or in some cases you'll have x minus n squared. And then we solved by finding the root, which was the process that we looked at previously. So let's look at another one here. X squared plus minus 10x plus 2 equals 0. This one's going to have a negative. So if I look at my b, in this case, it's negative 10 divided by 2 equals negative 5. Now, this is going to be an important number later on for us. So let's go ahead and just highlight that and then square it, and it equals 25. Negative 5 times negative 5 is 25. So I'm going to add 25 to both sides. Okay, 25 is what I added to both sides. And then this is where my negative 5 comes into play. I'm going to put x minus 5 here. So negative 5 minus 5, that's what we get. And on this side, it's going to be 23. Make sure we have that squared, because our next step is to find the square root of both sides. So x minus 5 is the square root of the left side, and the square root of 23, I believe 23 is prime, so it's just plus or minus square root of 23. So it's going to be x equals 5 plus the square root of 23, and x equals 5 minus the square root of 23. And those are our exact answers. Now you could find these with the quadratic equation, but as you see, it went a little bit faster when we were completing the square. So some people prefer completing the square over the quadratic equation, and some people prefer just doing the same thing for it all. Just master the quadratic equation and do that. And I don't have to think about completing the square. It doesn't matter how you get there, as long as you get to the correct answer. The path you take is up to you. All right, so here's another one for completing the square. It's already set up with our constant on the right side. So I can just skip step 1. I don't have to move C over to from the left to the right. It's already been done. But I do want to go ahead and write this out with a blank there, because I know I'm going to insert something in a little bit. So let's think of this. Half of 6 is 3. Square 3 is 9. So I'm going to add 9 to both sides. Right? And then I know this is going to be x. My plus here is plus 3 equals 8 plus 9 is going to be 17. Got my squared in there. And let's go ahead and square root these. And the square root cancels out the square. And we're left with x plus 3 equals plus or minus square root of 17, which is prime as well. So x equals negative 3 plus square root of 17, and x equals negative 3 minus square root of 17. And those are my exact answers. All right, one more. X squared equals 2x plus 11. In this case, my constant is already on the right, but I have something else on the right that's not supposed to be there. My term with a single x, with the x that's not raised to any power. I need to get that over back to the left. So if it's on the right and I want to switch it to the left, it's going to change sides. And if it changes sides, it's going to change signs. So positive 2x will become a negative 2x. My 11 stayed on the right, so it's going to stay positive. Now, let's look at this middle term. I have a negative 2. Divide that by 2, I get negative 1. Square that, I'm going to get a positive 1. Oops. Now, do I need to not forget to add it to both sides. And then I'm going to have here in my center, I'm going to have a negative right there because I have a negative there. So negative 1 and x. and then that equals 12. So in order to get rid of that square there, I need to square root both sides. And so I'm going to be left with x minus 1. Oops, don't need the parentheses anymore. Equals plus or minus. Let's think about 12 for a minute. 12, the square root of 12, I can simplify. The square root of 12, I know, happens to be 12 is 4 times 3. So it's the square root of 4 times the square root of 3. And the square root of 4, I know, that's a perfect square. So it's 2 square root of 3. So that's what I'm going to write here as my answer, because you should always simplify your radicals, simplify your square roots. All right. So now I'm going to have x equals, my minus 1 needs to move from the left to the right. So it's going to change from negative to positive. So 1 plus 2 square root of 3 and 1 minus 2 square root of 3. And those are my two exact answers. Oops. Now, sometimes you may see something with a leading coefficient other than 1 where, a does not equal 1. So how would you handle this if you wanted to do completing the square? Well, if you wanted to do completing the square, it is possible, but it might not always be pretty. What do I mean by that? That means it's going to have some harder numbers to deal with. It's going to have some you're going to have decimals and fractions and just stuff that's not fun to work with. So let's look at how we would do this. The first step is we need to make this so there's a 1 here. So how do we do that? We're going to divide every single term by 6. And if you think about PEMDAS, when you're undoing things, when you want to undo stuff, you usually start at the bottom and you work your way up the ladder, which would mean you've already completed addition and subtraction before you get to multiplication and division, which is why usually you can just start when you get to undoing a multiply, you would just multiply one time, right? You'd multiply the side you're undoing by, or divide the side that you're undoing the multiplication on just once by 6. But in this case, oops, I did not mean to draw that. In this case, we still have some addition and subtraction here that we haven't undone yet. So we have to make sure that we're dividing by 6 by every single term and not just this first term and then the other side. It has to be done to every single term. All right. So let's continue. This cancels out and we're left with x squared. This we can reduce a little bit, but it's not really going to, it's not going to go away. So it becomes 25 over 2x, 25 over 2x. And 36 divided by 6 is going to be 6. 0 divided by 6 is 0. Now we have 1 as our coefficient, and we can begin the process of completing the square. So you've got x squared. Here I'm going to write plus 25 over 2x. My negative 6, I'm going to move from the left to the right. And it becomes a positive 6. And I left a space here. So what's half of 25 over 2? Let's see. 69 divided by 6 is 11.5. 25 divided by 2 is 12.5. So I didn't do that right. It's not 25 over 2. 69 divided by 3 is 23. I didn't read my calculator correctly. It's 23, not 25. Sorry about that. That makes a lot more sense. 23 over 2. All right. So how do I divide 23 over 2? Well, essentially, you're just going to multiply the denominator by 2. So you would have 23 over 4 when you have 23 over 2 divided by 2. Let's see how that works. 23 over 2 divided by 2 over 1. Well, you keep, switch, flip. 23 over 2 times 1 over 2. So that is 23 over 4. Remember, when you're dividing, it's the same thing as multiplying by the fraction of the reciprocal. So 23 over 2 divided by 2 is just 23 over 4. And then we would need to square that to figure out what to add, right? So 23 times 23 is 529. And 4 times 4 is 16. So we're going to add 529 over 16 to both sides. Then you factor it, remember? So x plus, what's going to go here? This number that we were squaring is going to go here. So 23 over 4 squared equals, I think I'm just going to write the fractional form. Not the fraction, the decimal. And so that is 36.0625. 25. All right. I like that better than a fraction. And then we're going to square root both sides. Square root it. X plus 23 over 4 equals. You're not gonna, that's not gonna be a perfect root, but let's just double check. 36.0625 square root of that is, yeah, it's an irrational number. So what we have here, not just plus or minus the square root of 36.0625. And then you have over here, you're going to need to subtract that. Let's move on to this side. X minus, or X equals negative 23 over 4 plus square root of 36.0625. And X equals positive 22 over 4 minus square root of 36.0625. Okay, was that fun to do? No, it was so painful and annoying and just silly and messy and yucky. I didn't like it. There was another way to complete this that would have been a lot faster. You could have taken out your common factor of 3 and then possibly factored after that. That was one way. Another way is to do the quadratic equation. So completing the square will work. It will give you the correct answer. It's no fun when you get into decimals and fractions. So we've given you several ways to complete this that will allow you to get the correct answer. So when you see something with a number in place of the A, or so where the leading coefficient is not 1, I suggest not doing completing the square, but finding something else to do. So we've got some practices here for you. The practice is 3 questions. Go ahead and pause it and figure it out on your own and come back and we'll go over them. Welcome back. So let's go ahead with this. We already have our constant to the right and we have x squared plus 10x. Let's rewrite that and leave space for a new term here. Half of 10 is 5 and double that, I'm sorry, square that, we get 25. We're going to add to both sides. And then we need to, we know it's going to be like this and it's going to have what? A plus sign in the middle. And I know that I used 5 there and this is x and that's going to be equal to 7 plus 25. 32. Take the square root of both sides. You get x plus 5 equals plus or minus the square root of 32. 32 is not prime, so I know that it is, let's say 8. I know it's 8 times 4, so I'm going to put a 4 there. And I know 8 is 4 times 2. So it's 4 times 4 times 2. So I see a pair there that can come out of the house. So it's going to be plus or minus 4 square root of 2. These 4s, like we talked about before, the couple will get married, 2 will become 1, and they're going to move out of the house. The little radical is the house. The lonely only number 2 is stuck back in the house with his parents because he hasn't met a soulmate yet. So we have x plus 5 equals plus or minus 4 square root of 2. And so that's going to leave us with x equals negative 5 plus 4 square root of 2, and x equals negative 5 minus 4 square root of 2. And those are your two exact answers. All right, so this one we have x squared minus 20x equals 20. So the 20x here, I moved from the right to the left, and so it changed signs. It moved from a positive to a negative. My positive 20 stayed on the right, so it stayed a positive 20. Then I'm going to halve the negative 20, and that gives me a negative 10. I'm going to go ahead and write that down so I don't forget. Negative 10, and then we need to square that. It becomes plus 100. Write that in there. And so we get 120 on the right when we add 20 and 100. Okay, so now we take the square root of both sides, and I'm going to get x minus 10 equals plus or minus the square root of 120. That should be factorable. 120, let's see, 12. I know, let's say it's 10 times 12, and 10 is 2 times 5. 12 is 2 times 6. 6 is 2 times 3. I see a couple right there that wants to get married. So let's make sure this works. 2 times 5 times 2 times 6 is 120. So that is going to be 2 square root of 6 times 5. My lonely only staying inside the house are 30. These 2s, since they're a pair, they're a couple, they got married and moved out of the house and became 1, number 2. And then 5 times 6 stayed in the house, so that's 30. All right, so we've got x equals 10 plus 2 square root of 30. I took this negative 10 from the left and moved it to the right. X equals 10 minus 2 square root of 30. When I move it to the right, it changes from negative 10 to a positive 10. And those are my two exact answers. All right, so here we've got x squared minus 6x equals 39. I've taken my negative 39 on the left and changed it to a positive 39 on the right. Now I want to take negative 6, and I'm going to divide it by 2. It becomes a negative 3. And then if I square negative 3, it becomes a positive 9. I'm going to add that to both sides. 39 plus 9 is 48. So let's do the square root of both sides. Square root of 48, I'm pretty sure they can be divided by 4. It gives me 12. So square root of 48 is going to be 4 times 4 times 3. Let's make sure that works. 4 times 4 times 3 is 48. And then I see a pair right there looking to get married. They're going to the altar. They're going to get married. And so my lonely only 3 is left in the house. So my answer is x equals 3, because my negative 3 moved from the left to the right, so it became positive, plus 4 radical 3, and x equals 3 minus 4 radical 3. Those are my two exact answers. And now you know how to complete the square. Again, I say figure out which method works best for the problem that you're working with. So you may have a preference of methods and want that, but forcing it to work sometimes it just makes it complicated. So you want to go with the one that works best for the problem, because you want your life to be easier, and math is fun when it's easy. All right, we'll see you at the next lesson.